Welcome to ASME TechCast, bringing you the innovators, the innovations, and the issues that push the envelope of engineering. Today's conversation is grounded in the core focus of the ASME Catalyze Summit, turning promising ideas into real-world sustainable solutions at scale by connecting the engineers, industry leaders, and partners who make that progress possible. We're joined by Caroline DeWitt, co-founder and COO of Oklo Incorporated of Santa Clara, California, a designer and deployer of advanced fission power plants, providing clean, reliable, affordable energy. Oklo is a foundational sponsor of ASME Catalyze and the sponsor of today's episode. Caroline, welcome to ASME TechCast. Thank you for joining us today.
Thanks for having me. As a mechanical engineer, ASME is something I've always cared a lot about.
That's awesome. I'm so glad to hear that you're know of ASME and that you're also a mechanical engineer. We love supporting engineers and hearing from you and hearing from your perspectives on what's going on in the field. Speaking of that, from your perspective, what's changed the most in how the industry talks about advanced nuclear, and why is it such an important part of the conversation right now?
Yeah, I feel like what's changed a lot is it's more real now. I feel like when we first started Oklo, which is 13 years ago now, it was people were like, yeah, that's cool, but it's in the future, which granted it was. But now we're actually building, and us, not just Oklo, but some others too. And so I think it's really transitioned from where it was on paper in regulatory space to actually building, and that's really huge.
Yeah, what do people, especially from outside the nuclear industry, still misunderstand about what it takes to bring advanced nuclear from concept to commercial reality?
I'm going to say something maybe a little controversial or like maybe a take that not everyone has. I think historically people have always thought, yeah, that's really cool, but you can't do it because the regulator. And certainly the regulations are not easy, and they were definitely built around what I'd call older technologies. In a way, they're all old. Fission is old, but at the same time, it is built around a very specific technology in terms of the regulations. So I think you kind of had this steep hill to climb anyway, even if you were a water cooled reactor, which is what the regulations are built around. But on top of that, being a different technology that the regulator's not used to seeing or hasn't seen in quite a while in different ways, then it makes a hard hill to climb even harder. But I would say that is not actually the hardest thing, and probably the thing I see people misunderstand the most about what we're trying to do here. And I'd say for us as engineers, I think like the focus tends to be on the tech, and I think in the nuclear energy space, the focus is on the tech. Like, well, I have this technology or I have this technology, and I honestly saw a lot of that because in between undergraduate and grad school, I worked on taking technologies out of our university and trying to commercialize them and seeing which ones had the most promise. And it's not about necessarily a new widget. Most cases, I think it's about the business case. And I think the toughest thing around nuclear was really how would you not just have a new widget, but or a cool technology, which matters, but like how do you actually get it financed all the way through to building plants, and how do you have a business model that customers want to buy? So I think that's really a big misunderstanding of not just engineers, but I think the public at large is like kind of an assumption of like the technology is what's key, and I think it's really the business model.
That makes sense. I feel like a lot of times you can have a really cool idea and something that might be so revolutionary, but it's getting it from that initial idea to getting it out where people are using it, and it's actually making a difference in the lives of people that would benefit from it. And speaking of that, Aurora is one of those revolutionary technologies. And I'm wondering, like, what makes it different from other small modular reactors? And from your perspective, why is this difference crucial to your success?
Well, I will say, so the technology we've leaned in on this basically this whole time is around fast reactors, and specifically what's called sodium cooled fast reactors, which have among the most experienced set of any advanced reactor type. Um, Basically, they do have the most experience outside of water cooled reactors. There's been about 500 reactor years of experience globally in this type, and so what that means is you've got a lot of fuel data to pull on, even operational data. And that's really important when you're talking about how to get through the regulator. You have to have that data to show how it performs in all kinds of scenarios. So there's a long history in the United States, but also globally, demonstrating these reactors. Specifically, we lean heavily on the experience of what's called the Experimental Breeder Reactor 2, which operated in Idaho from the 1960s to the 1990s. So about 30 years of experience there. And they did all kinds of things with that reactor. And one of the things that makes it really special, but there's a lot of different ways that a lot of different reactors have safety characteristics. But the thing that we find most compelling about this type is they literally had it at full power, lock the control rods out of the core, so like no shutdown rods, and shut off the coolant pumps. And I say just to see what would happen. They predicted and they knew what would happen, but basically it shut itself down naturally and didn't even have any fuel damage. So people worry about, obviously meltdowns and releases of radioactive materials. And it just shut itself down naturally and without any damage. And so it was able to start right back up. And so that's kind of the worst case scenario where you don't have any shutdown rods and you don't have any coolant. And so once you've kind of shown that worst case scenario is okay, then that really shows that there's a wide range of operating experience that means this reactor can stay safe under. And I think that's one way we want to address how to meet the regulations and beat the not just meet them but exceed them, is so to speak, is by having a reactor that inherently does that and has that capability. So to us, that's really important. But the other thing that this reactor type can do that's really unique to fast reactors in general, regardless of coolant, is the ability to use waste as fuel. And this is not just a cool PR point or something that's like, oh, that's a nice to have. It's like, that is a unique source of fuel in a world that's like, hey, how do you mine it? How do you enrich it, etc.? You don't have to mine and enrich recycled fuel. You can take it and process it and then utilize it as fuel. And there's so much energy left in the fuel. The traditional water-cooled reactors that exist, roughly 100 around the country, probably about 90 operating now. They're water cooled, and they use about 3% of the 3 to 5% of the energy before unloading that fuel. And the reason is those type of reactors can't make use of that other 95% of the energy in that fuel. And fast reactors can, because they can fission so many different things. And so without getting too in the nuances, hopefully you hear my excitement anyway, is that you can really make use of like a good portion of the rest of that 95% of the energy that's just sitting there locked up. And so that's what we're excited about doing. We also believe it'll lead to lower costs and a better domestic fuel supply, and simpler kind of, in a way, fuel supply chain, so to speak, because you don't have all these extra steps along the way or sourcing required from other countries. So it has a lot of benefits. So that's kind of why we started with that. But I think, to get back to what I was saying in your prior point, it's not just about the technology, it's about the business model. What we've seen is really customers don't want to own and operate a reactor. They want clean power. And so our business model has always been to own and operate the plant. And because of that, we are the ones that not only design it. So there's a lot of designers out there, they want to get regulatory approval on a design and then sell that to utility, who then has the responsibility to buy the fuel, to own and operate it, to build it, etc. We want to own the whole life cycle, partially because of that recycling component, because we see value in the ownership of the fuel and the operations of the plant over many decades. So it's something we've been thinking about since the beginning, is how do you make the most use of these resources over, honestly, close to 100-year time scale.
Very cool. So it sounds like you've got a couple different like cycles going on. So you have the cycle of the Aurora itself, right, with using the recycled waste. It can shut itself down, come back on, so it's inherently safe there, which definitely enforces trust in the brand and in nuclear energy, right? Because you hear so many horror stories, especially now with a lot of documentaries coming out about like what can happen with nuclear, and that really, having that as a peace of mind, really, I think enforces like, oh, like this is, not only is this something that we need to shift to, but this is something that we can shift to and do so safely. But you've also got the business perspective where you're owning and operating all of it so that people get the clean energy that they want. And it sounds like lower cost, right? Like it's a win-win. talk to me about the 75 megawatts electric. I know about engineering concepts, but I wanna think about that scale. Like, how does it make that compelling from a market and deployment standpoint, especially for someone who is interested in engineering but might not know exactly what that means.
Yeah, I mean, there's markets for each different size range, I'd say, and a lot of it has to do with financeability of each size of plant and the different things you get into with different sizes. So, for example, depending on where people started learning about Oklo and its journey, um, we started off with a 1 megawatt plant because we did see a need for these remote applications, smaller plants, et cetera, kind of more of large campuses, hospitals, mining, that sort of thing. Um, and as we got into it, maybe obviously, but there's a lot of customers in the space where they're like, that's nice, but we need more. But we started off there because we felt like, one, it'd be easier to regulate, easier to put in our first application for something so small, it almost looks like a research reactor, and just really get our feet wet there. But also because we felt like that was a size that was financeable from a venture capital funded kind of company size. And so that's where we started. But yeah, increasingly our customers were pushing us larger. And, we were able to access more funding. And ultimately, that's long story short, we landed at 75 megawatts. The maybe interesting thing to people is that there's not a huge amount of fuel difference between the 1.5 megawatt and the 75. There is a difference, but let me give you an insight. So, what we were originally looking at was a 1.5 megawatt heat pipe cooled reactor, which also meant the heat pipes are carrying the heat out of the core and translating that into the heat that basically turns into steam and turns into energy. In general, you can use different cycles, but heat pipes they move heat quickly, but not very much. And so you're really limited by how much heat those could move per amount of fuel. And so you really have this low power density. And so one of the things that was cool about moving from there to a pool type, it looks more like the EBR2 in a sense, having a pool of sodium versus heat pipes with sodium inside of the heat pipe. But the pool can actually move a lot more heat. And so with a roughly similar amount of fuel, you can go up to 15 from 1.5. So basically a 10x amount of heat transport. And then we found out that sodium pumps were actually more advanced than we thought they were. And with time, they became that way over the last decade. And so we moved from there to a pump design, which actually looks even more like EBR2 because it used pumps. And so from a regulatory perspective, it's a little more straightforward to utilize that data. But also, you can really move heat because the pumps are actively moving the sodium instead of it just kind of heating up, rising, and then cooling and falling down for those that are familiar. So that's where we get to the 75 megawatt. And that's kind of the technology evolution that got us there. But really what we were seeing is customers were wanting to scale faster, and we were talking to bigger and bigger customers that were looking at those areas. And as we were able to go public and really raise the kind of capital to be able to finance larger plants, that enabled us to move to that larger size. So we see it as kind of a sweet spot in terms of you can have multiple to add up to a large number, or you can just start with that depending on the customer appetite. So it's kind of more modular, so to speak.
Awesome, awesome. So, what would you say are some of your biggest milestones, and what have been some of the greatest setbacks in designing and deploying this technology?
I think the single biggest one was going public and being able to do that successfully. That has enabled us to raise now billions of dollars in private capital. That has really enabled us to finance and execute on this mission. That's on the kind of corporate side. I'd say on the regulatory and government relations side, um, we've seen bipartisan support over a lot of years now, like basically the entire time at Oklo. Like I remember back in 2015, the first time we talked at the White House, Jake, our CEO, talked there. It was under the Obama administration. I think Trump won further accelerated advanced nuclear. Biden continued that, and the Congresses that were during those time periods as well. And then Trump too, even more so. But I think the single biggest step would be tied back to the executive orders that happened about a year ago this time that allowed for the Department of Energy to basically kickstart construction in this area. And I think that's been huge to allow the NRC, the Nuclear Regulatory Commission, to work with the Department of Energy on novel reactors and really start everyone starting to get their feet wet in how construction looks, how it should look, and kind of giving that training wheel that then the NRC can utilize and look at. Because I think no matter how much data you had, it was very hard to get to yes. I think infrastructurally, like that's difficult for any regulator of a new thing. And I think the Department of Energy's, mandate is to do research and development in nuclear energy, and then the NRC's job is to regulate commercial nuclear power. And so I think that kind of hand in hand capability to allow for construction to start in these places and allow us all to learn together has been really huge. So it's incalculable. Since a year ago, we've been able to start from shovels in the ground to substantial completion of an isotope test reactor in 220 some odd days. We've also been able to start construction of our first power plant, which is now hopefully going to start safety-related construction here in the next month or so. And so I think there's so many things that people didn't know they didn't know because everyone was stuck in the regulatory stage up until now. And now it's like, oh, we can flex these muscles and learn about how we need to set up procurement and construction and contracting and operational procedures and all these things that, again, are beyond the widget itself, but really important factors to all tie together, quality assurance and all these different processes that all have to go hand in hand as you're constructing and in preparation for operations. So it's been, I think those are the biggest milestones is the EOs and our ability to go public a couple of years ago.
That's great. That's great to hear that not only have you gone public, but you've had a lot of support from both sides of the aisle where everyone's like, all right, this is the direction that we clearly need to go in. That must be really empowering for Oklo and for just, I think, the nuclear industry as a whole, right? Having everybody, as you said, like get their feet wet, like being able to actually break ground and move past like, oh, this is our cool idea, what next. Now you have those connections with different people, which is what Catalyze is all about. We're trying to connect the people that have the ideas with the people that can make them happen. And another big focus of ASME's Catalyze Summit on accelerating sustainable industrial transformation is moving from first of a kind to repeatable systems that can be fully integrated into businesses, cities, whole systems, you name it. So from your perspective, what does designing for the 10th or 100th unit mean, from the very beginning stages to doing it over and over again? And how is this concept demonstrated in Oklo's Aurora technology?
Yeah, I love that question because I think when people ask, like, how are we different? And not to fault anybody, but I think so many companies are just looking at let's get the first plant built. And that's a reasonable expectation. But I think we've taken a lot on ourselves, but set the groundwork for the 10th and the 100th, and et cetera. Because to us, and we say this all the time inside our company, if we just build one, that's a failure. We haven't really made an impact, right? Like if our goal and so much of what we hire for and our team is aligned on, like all this mission alignment of like, let's make an impact on the world, like, right, for clean power, for power availability, for ecosystems, or whatever personally motivates each person on our team. But we're all mission aligned to like this ultimate goal of deploying a bunch of these, hundreds ideally. And it's like, what gets us there? And I think we've had to think about so many things that many companies are not yet to, but they will get there hopefully for all of us, which is like, how do you license a fleet of operators? So we've been working with the Nuclear Regulatory Commission on what's called a topical report, but it's basically a concept paper. It's more than a concept paper. It's a methodology that we're hoping they approve in terms of how can we train operators to not just operate one plant, but hundreds, and we can utilize that staff across a country or the globe. And you see that in other industries where they train people such that they can go interchangeably to different plants and utilize them during things like outages and things like that as staffing needs grow and evolve. I think that's maybe one example, but of many things that we're thinking about how does this scale. We're also thinking about the entire supply chain and how do you build it not just for one or for 5, but what does nth of a kind look like for supply chain? Now, we can't bite all of that off right now. And I worry that sometimes in nuclear, people have been like, well, if your goal is a manufacturing plant, then you can't build your first one without a manufacturing plant. And that's not exactly true. I think you can see, like, anyone can look at kind of these cool, helpful, hard tech examples, like Tesla. They started hand making cars in a shopping mall in California, right? And then they scaled up. And so our first couple are not going to be what our nth of a kind are. But at the same time, we're thinking about that and scaling towards that and thinking about that as we think about how our supply chain is. Maybe an example of that that's publicly visible is just our acquisitions and how we look at them. Recently, we announced one related to machine shop and manufacturing. So we're actively investing in components that will scale to build our supply chain. So it all gets back to, though, like our business model. Like, if your business model is to make a design, get that design certified by the regulator, and sell that design to utility who then builds, owns, and operates, you're not necessarily thinking about a fleet and how to operate it and how to have security for it and how to make that cost effective over 80 years. Like, you're thinking about the design and what will a utility buy, and then it's their job to figure out the rest of it. So I think because of our business model, we see the upside, but also we have that challenge and impetus to really think through those complex things as you look over many plans, ever growing in many years and decades. So that's how we look at it.
Right. It sounds like you're looking to accelerate your deployment, right? And like take steps forward, but you're also taking things one step at a time and leaning on your strengths and using what you know, right? Because I mean, you're right. Like the first iteration of something that's not going to be something, 5, 10 years down the road, but you have an idea, you're going to make it happen. You're going to build it, and then you're going to see what happens down the line and maybe better ways of making it or better ways of managing the system and constructing things come along that make that easier and simpler. Um, if you could bring together like all the people that were needed to accelerate deployment, whether it's people from a construction side, a regulation side, business perspectives, what would that conversation focus on first? What is that? What do you need to address off the gate?
Let me know if I'm not answering the question, but I think the first thing that pops in my mind when I hear that question is just the really significant importance of our relationship right now with what we call an EPC. And we have right now a really strong relationship there. And that's another thing that I failed to mention the prior thing, but I was giving certain random examples, but I'll give this one here is like a relationship with an experienced EPC right now, but also scaling to the future. Like, they're motivated and we're motivated by success, even on our first of a kind. And to your point, like, the success of the first of a kind doesn't necessarily always translate into the fifth or nth of a kind. But I think, like, they have incentive to do well because we're all looking towards second, third, fourth, fifth, and et cetera. And we're already having those conversations. So it's really cool to kind of see how that's been important. And it's been important in ways that I didn't necessarily anticipate even before this year. Um, you know, uh, I think maybe it's even to the layperson kind of obvious, like, oh, someone's going to construct it and like have the big machines out digging holes and pouring concrete and so forth. But it's also like they know things about labor markets across the country because they operate all across the country. They know things about, I mean, that alone is huge. They know things about building codes across the country. They know things about just even like um, common what's an appropriate amount of time to budget for something, because they have huge data sets of like, oh yeah, we've welded this many pipes of this size and this is how long that should take, or things like that. And so it's been really fascinating to get to know them, work with them, and we're both incentivized towards success. So when you said, I think your question was, what does that team look like? And
Mhm.
obviously it's engineers, but it's so many things. It's business people. It's regulatory engineering. But I think what's hot on our minds right now is those boots on the ground and our relationship with the EPC to translate those designs into reality. And we're using lots of consultant support and engineering support, and we've got our in-house engineers and all those things. But I think as far as the pie, I think that's still actually it's the biggest part of our company for sure as engineers. But in terms of the overall pie of people who are going to be involved in making a project a success, it's I don't know if I'd say it's dwarfed, but there's increasing numbers of all these other people that really have to play in, permitting people, et cetera. But I really think the EPC is going to be like right now, for example, at the Aurora INL site every single day. We have around 100 people, and that will only grow as we get into different aspects. And our entire engineering team is probably right now something like 200. So that's just one site, and we've got another bunch of people working down in another site for the isotope reactor, and we're starting up other sites in Alaska, Ohio, et cetera. So I can quickly see how I think engineers we tend to think of our part as the most important, but I think someone takes our designs and makes them into reality, and that takes a whole cast of characters that maybe aren't immediately obvious, which has been fun.
Wow, that sounds so it's so interesting to hear from your perspective because it really does take a team to make these things happen. And there's so many different things that you wouldn't otherwise think about when you're trying to get to that deployment stage. So I really appreciate your insights there. And yeah, we are so excited to have Oklo as a foundational sponsor for Catalyze, especially with different perspectives and feeding into the idea that we want to get these ideas out into the world, ready to go, ready to use to make our planet a better place. So I want to ask you as our final question, what unique value will Oklo bring to the Catalyze community and how will it enhance the experience and outcomes for participants?
I will admit, in the past, I've been like, we know what our values are, and it feels a little cheesy to like list them out or like pick company values, and it's like I feel like we should just know that or something. But we went through this exercise, and I would say it did crystallize for me, and I think a lot of us what our key values are. So it's hard for me to pick one. So I'm going to cheat on this question, but our values are collaboration, humility, ownership, and pathfinding. And I think it takes at least maybe three of those together to really do what we're trying to do, because so much of it the humility comes in terms of teamwork, and that's the collaboration part. But ownership and pathfinding are another big part that tie into that. Is like each person has to do their job, but also so much of what we're doing has never been done before, and there's just no path. There's no clear like, okay, if I do this, it's been done before, and I just need to execute on it. And there's no shame in that. Like, there's so many businesses that the execution path is relatively straightforward, but there's a huge opportunity set. Like, I think about like we have friends who did startups in HVAC. Like, people have been doing HVAC, like air conditioning forever, but to do it with their business model is unique. But like in our case, like literally no one's built a commercial recycling facility for nuclear power ever. I don't think in the world, but at least in the United States, or no one's licensed to the point of like an operating. Like no one had done a combined operating license ever before for advanced reactors. So like that has just never been done. So you just have to pathfind and be. We try to find team members that are have that mindset of like no one's going to tell you what the right answer is. Like you've got to actually find it yourself, and we're relying on you to do that. So anyway, I very much cheated on this. I didn't even pick two, I picked four, but those are our values, and hopefully, I would think we bring that to the table with whatever we do at Oklo.
Absolutely. Well, again, we're so excited to have you. Thank you so much for sharing your insights, and it's been a pleasure to have you on the show today.
Thank you so much, Connor. Great to be here.
And for our listeners, thank you for joining on today's episode of ASME TechCast. If you'd like to learn more or be a part of the conversation shaping the future of engineering solutions and accelerating sustainable industrial transformation, please visit catalyze.asme.org. And if you'd like to hear more great conversations on a wide range of engineering topics, please subscribe to the ASME TechCast on your podcast platform of choice. Thanks so much for listening.